So let's start. Before that, Chumei pinged me offline that she cannot make this time stand up because she was on vacation last week and attended the Summit One. Probably it's a conference held by Intel. And regarding me, I was on PTO last week also and created a couple cleanup PRs, and I just started reviewing some PR to add the garbage collection, and I will also looking at the Amnon's PR and Ronan's, and hopefully could allocate enough time to looking at the Xuehan's Interrupted Future as well. That's me. Ronan.
Hi, thank you for planning to go over the PR. I'm waiting for comments. Apart from that, I'm starting to work on some improvement to the testing, starting from the standalone tests for scrubbing. And that's it for me.
Sam?
Yep, I spent some time reading Xuehan's PR. We should probably talk about that a little bit at the end of the meeting. I submitted the PR that Ifu is looking at now, and I am writing a disk backend for SeaStor so that I can start doing some basic performance testing of the transaction manager level. That's it.
Just out of curiosity, Sam, are you going to using ZBC or ZBD?
And we're using
for writing to the disk? ZBD, libZBD, or just using the
right. Oh, okay. So I have a couple of things I want to talk about there, actually. One of them is that I'm going to use the simplest, most basic thing that's already built into SeaStor at first. I believe it's just libaio. That's the first thing. Mostly because I don't myself own one of these ZNS devices. I can use a library that emulates it, but that won't tell me anything about performance because it'll be running on top of a conventional SSD. So in that sense, it will be identical to doing what I'm already doing, which is doing writes in a manner that is consistent with, but not actually limited to, a zone device. The question I had, though, was that I assumed I was going to be using IOU ring, and it looks like IOU ring support is not merged. Does anyone know anything about that? Curiosity.
What do you mean by using IOU ring? I think the libaio ring support has been merged in.
It has not been. But look, some preliminary wiring was added in March, but right now the backend doesn't use it. There isn't any lib, like it just flatly doesn't use it. The syscalls are not present. I was wondering if anyone had heard anything about it. I assume they're just still working on support and it's not merged yet, which is fine.
You mean this? You mean this? The libaio ring backend of SeaStor or libaio ring backend of BlueStor?
SeaStor. I don't care about BlueStor at all. I don't particularly want to write a libiou ring backend for SeaStor. I'd rather than write it for me.
I believe it's been already merged, but I'll take another look at it. Anyway.
Thanks. As far as I could tell, it hadn't been. The last reference I saw to it was a patch from March, and I did check their master, not our branch, which specifically said they omitted the actual libiou ring support. It's just a refactor patch. So I think they're still working on it, but I'd be happy to hear otherwise. Either way, my guess is that the way they're intending to do this is that the existing interfaces will just magically start doing libiou ring when it's supported, which is I am very happy about. So it's not really a matter of urgency. I'm just curious.
Yes.
I'm probably not going to bother with actually trying the libz something, the thing that emulates a ZNS device until I actually have one, simply because I don't think it's an interesting performance benchmark. It'll be useful if I need to write something that works against that library, but until then, I won't.
Yes, my guess is that probably the writing interface could be different.
Yeah. It'll be different, but not in interesting ways. I already have an interface boundary. I'll just write a second segment manager for it, or a third one rather.
That makes sense. Xuehan.
I will take a look at it though, to make sure I haven't made any choices that are problematic.
Okay.
Last week I was submitted the interruptible future PR. Here it is, and right now I'm trying to modify the code and add some unit tests and in detail explain just as Sam suggested. No, that's all for me.
Sam, do you want to discuss with Xuehan regarding to his interruptible future?
Yeah.
A little bit.
So initially, I was a bit confused, but I think I need to spend some time reading this in more detail to make sure we haven't missed anything. But I think he successfully closed all of the ways in which it can break. But I do have this concern, which is that it introduces dynamic changes in behavior to called methods. This is by design. Xuehan, you referred to it as the OSD mapgate problem, where depending on the caller to OSD mapgate, we either want to check for the PG interruptible or not, or perhaps a different one. I argue that we don't want that to be variable. In nearly every case.
So I think you mean that once we define some method to return interruptible future, then the continuations in it will be interrupted. Am I right?
I think they should assert that the interrupt state has been set up. In other words, does that make sense? In other words, it needs to be a precondition. I think it will be more useful that when you create an object of type interruptible future, whatever, templated on a particular interrupt type, I think it should assert that there is an interrupt condition that on the thread at the time when safeThen is called. In other words, it's illegal to call safeThen without outside of a with interruption wrapper. I think that's the right way to do it for two reasons. The first is that it makes it easy by inspection to work out whether something is interrupted or not. The second is that it makes it easy to rule out certain categories of bugs. It means that a particular piece of code will always be interrupted or it will never be. It will either always have the interrupt condition embedded or it will never have it embedded. And I think there are going to be almost no cases where we don't want this. OSD mapgate might actually be the only one. If you look at classic OSD, you'll notice that we never do this. Essentially, every callback unconditionally checks the PG interval change. I can't think of a single case where it's optional.
Okay, I got you.
I'm open to an argument, though. If there genuinely are cases where this would come up, or we want it to be possible for it to be variable, I'm open to that. But I'm deeply afraid of bugs where a piece of code accidentally stopped having its interrupt condition attached. Concretely, what this usually looks like is, for instance, if an op goes to sleep on some resource, that is, for instance, an object context lock within the OSD. During the interval change, we're actually going to throw away that object context. It's going to go away. And the in-memory state that represents it will simply stick around until all of its references go away, but we're never going to truly release that lock. So if we're relying on the interrupt condition to wake things up, then if we didn't have that embedded, that op is going to wake up and continue to operate as though the PG were still in the previous interval. It won't reset itself and put it back in the queue. So we'll get these weird, very difficult to debug situations where things were supposed to reset themselves but didn't. And I argue that that cost is really high. We really want to make that as impossible as we possibly can.
Okay, I got your point.
But again, I'm open, like if there are reasons why we might want to do it that way, it's possible. But my suspicion is that we probably don't.
Tim, so your argument is that... Please go on, sorry.
Nothing. You go ahead.
Okay, thank you. Sam, your argument is that the behavior of interrupting future is determined at a compile time. Is that what I mean?
No, it's not. It's still not determined at compile time, annoyingly. The way Joyhan has written this, and you should read it because this is a large departure from the way we currently do these things. It's highly dynamic. At the top of the call chain, when we're setting up the state for an I/O, we create some thread local state that will simply ensure that every call to safe then, nested dynamically below that within the call stack, will transparently add this interruptible condition as a parameter.
Oh,
this is a pretty standard library technique, but it's really invisible, and if it ever breaks, we're never going to debug it. So that alone is a thing we should all be aware of. Like, this will not be easy for contributors to understand.
You mean we should make it explicit, right?
Well, no. This design specifically doesn't make it explicit. Making it explicit would be a different choice. What I'm saying is, by choosing to do this, we do make it more difficult to forget to add it, but we make it easier to create other kinds of bugs. And we're just hiding an important detail from readers of the code who aren't aware that it's there. Granted, it's one big one, and it's almost every single call to safe then will need the state added in otherwise. So it does save us a lot of work. Another possibility is we could make it so that this future wrapper doesn't have a safe then method. It has a safe then with implicit interruption. That way, the reader at least has a hint that they're not looking at a standard. Actually, I think that's a good answer. Actually.
So I think what you are suggesting, Sam, is that I assert in the interruptible future interruptible future's continuation. When I try to reference an interruption condition, there must be one.
It's a little bit tricky, actually.
To make sure.
It's a little bit tricky. So when there are two methods in play here. One of them is the safe then method itself. So that's called synchronously in the original thread. That is the thread that's setting up the callback state. That method, I think, should assert that no matter what, the previous state should already have been set up. Either it's being called from the context of the original, like the originator of this thing that called it nested under with interruption, or it's being called from a nested continuation where the very first thing it did was reset up the interruption, I'm sorry. In either case, it must always be the case that when safe then with, whatever I called it, safe then with implicit interruption is called, this state must already exist. It's not permissible for it to be optional. If we want it to be permissible for it to be optional, we could add another version of this method that doesn't assert that, which I think would be a valid choice. Oh, and if anyone has a good idea for a shorter name than safe then with implicit interruption, I'm fine with that too. I just don't think we should call it safe then. I think it should be distinct, and it should have something that implies that there's more going on with respect to an implication, to an interruption, than the user is aware of. In other words, they should think, wow, that's weird, I should go read that code.
Okay, I get you.
Anyway, so I think that's the state of play, and I think, on balance, this is a reasonable approach. I, indeed, don't actually want to have to list the interruption condition for every single call to safe then. It'll be busy. It'll be exactly the same efficiency-wise, but it'll be busy. Source code-wise.
Yeah, I agree with you.
It's like, honestly, Joanne, anything you can do to make the actual implementation easier to read and to make it so that like the nested namespaces are a little less cumbersome and it's just generally simpler will be good. We need it to do as little as possible because it needs to do so much. So we want it to be simple. Because several of us are going to have to read it and essentially prove that it's correct from a language semantics point of view, which is not easy.
Okay.
But I think you've thought through everything. I think this will work.
Anything else? Nope. Okay. Talk later, and thank you.
Thanks.
Have a good one. Later.
Thank you. Bye.